So, we have been looking at the space group C2 unique axis B, but what is one issue which we have to keep in mind is that the presence of the y axis is not unique, the 0 of the y axis. That means the origin can be anywhere along this direction. So, suppose we move the origin to this 2-1 screw axis, what happens? We have already discussed this issue. Suppose I take this origin and move it to this particular point, now it becomes C21, the space group becomes C21. So, we already showed that C2 and C21 are one and the same. So, it is necessary to specify the origin, and we say here origin is on 2. That is why the international tables is very careful, very cautious. So, they say the origin is on 2. If the origin is shifted to the 2-1 position, it will become C21, but these two are one and the same. So, the question of fixing the y value is crucial here, and that y value is put at 0. So, this will be the 0 0 0, that is the presence of the two-fold axis. If we look at the possibility of special positions here, interestingly special positions do develop. That is why I defined where the origin is, and once the origin is fixed, then the special positions will come at any value of y. So, the value of y is dependent upon where you fix the origin. The origin is fixed at two-fold axis, then two special positions come up, and those are A and B Wyckoff notations, and these have two equivalent points, because the total number of equivalent points here due to 0 0 0 and two-fold is this, due to the presence of the C centering this is that which we have already indicated in the diagram. So, we have come to a stage where we have finished all the possible symmetries that can be associated with a two-fold axis. Now, the reflection conditions, as I mentioned, we will not worry about it now. We have already prepared this slide, so let it be there, but we will look at this slide in more detail when we discuss the diffraction conditions. Of course, one can discuss the other space groups like PC, PM and so on, but that is not the idea. As I told you that it is not required here to learn all 230 space groups. So, instead we now go to the space group P21 upon C. P21 upon C I have been mentioning again and again that this is a space group where we find most of the organic compounds go into, and therefore, it is better we understand this space group a little more clearly. Again, this is the space group number in this case is 14. So, we have now jumped from the space group 5 to space group 14. The arguments which go with the definition of the asymmetric unit, the special positions and so on will be very similar in the other space groups from between 5 and 7. So, we do not have to go into the detail of it. So, we go to this space group number 14, very important space group. The unique axis is taken as B, and the full symbol is P1 2-1 by C and 1. You see that 2-1 by C will convert itself to a point group symmetry of 2 by M. So, the moment we see 2 by M, the system has to be centrosymmetric. We have learnt it already. So, since the system has to be centrosymmetric, the origin must be at the center of symmetry, that also we decided. And in fact, we derived the equivalent points of P21 upon C in the previous class based on this. So, here you see that the origin is the center of symmetry. The presence of the 2-1 screw is at 1/4 the distance, and then you see the presence of the glide plane, which is shown up here because it is coming in a direction perpendicular to that, and that is also at 1/4. That is also at 1/4, and therefore, we see that the two-fold axis, screw axis and the glide planes are shifted by 1/4 and 1/4 This is shifted 1/4 perpendicular to that, and this is the nomenclature which we learnt long ago in the earlier classes, and this is the 2-1 screw axis which is now appearing at 1/4 the position. So, if this diagram is given again and nothing else is given, is it possible for us to guess the space group? It is fairly simple now, very easy, because we see the center of symmetry. So, we know it is a center symmetric space group. 2 by M symmetry is center symmetric. So, we say that this system is center symmetric, and we see a 2-1 axis 1/4 removed and a glide plane 1/4 removed. We have understood that whenever there is a translational periodicity involved space group, the systems with the no translation symmetry, they move by 1/4. In this particular case, both the systems 2-1 as well as C has the 1/4 movement, and therefore, both of them move by 1/4. One moves with respect to the other by 1/4, let us put it that way. So, we therefore have now this equivalent point diagram. Now, looking at the equivalent point diagram, is it possible for us to identify the symmetry element? So, if you look at this point to this point, you get a center of symmetry. You look at this point to this point, you will get a 2-1 screw axis straight away. Okay. So, you therefore have this and a 2-1 screw axis. Now, the fact that there is a center of symmetry here brings a center of symmetry here as well, and these two therefore are related by the center of symmetry. If these two are related by the center of symmetry and these two are by the 2-1 screw axis, then there must be a possibility of a glide plane which is placed at 1/4 the distance, because these 2 points will not be generated otherwise, and this is one of the points which is generated by the C glide system, and therefore, you have 4 equivalent points. These 2 equivalent points again are related by the presence of the center of symmetry here. These 2 are related by the presence of the center of symmetry there. These 2 are related by the 2-1 screw axis. Compared to this diagram, you can see that these 2 are related by a 2-1 screw axis. These 2 are also related by a 2-1 screw axis. The fact that we are adding half to the symmetry related one here and the half to the symmetry related ones here tells us that there is a possibility of a glide plane at 1/4. So, this is therefore a uniquely determined space group. So, we have the 1/4 translation along the direction which is down here, which is the C direction, the 2-1 screw axis developing, and 1/4 which is along the B axis, which is the unique axis in case of P21 upon C. So, the equivalent positions, in fact, the asymmetric unit now is very interesting. The asymmetric unit is the y value, which is the value perpendicular to this, stops at 1/4, and the other 2 are in the full unit. So, that means that we again have 2 molecules in the unit cell. Now, that is interesting because we should get only 1 molecule in the unit cell. Now, do we get 2 or 1? We get in fact only 1, because the x value is full. So, the x value which is up here is full, and then the y value is only 1/4, and the z value is also full. So, we get therefore this plus that as the unit cell identifiers, but then you see that these 2 are centrosymmetrically equivalent objects, and then there is a half translation in a direction perpendicular to that. So, it goes again beyond the 1/4 plane. So, this is only 1. Let me explain again. The number of equivalent number of points in the asymmetric unit here in this case is only 1. It is because of the fact it is a primitive lattice. So, in a primitive lattice you should have only 1. In a C centered lattice you should have 2. In a F centered lattice you will have 4, and in a body centered lattice you will have 2. The symmetry positions then give us the equivalent positions in the entire symmetry. So, here you see that this, if you consider the asymmetric unit as this one, since we are stopping at 1/4 along the y direction, this point will not come. This point, none of these points will come, and therefore, we will get only 1. So, when we get only 1 object, it means that it is primitive. So, these are all fairly consistent with the mathematical theory of groups, and group theory straight away proves all these points. But then when we are visualizing the crystal structures, we cannot think of group theoretical principles. Instead, we can think of where the molecules are, where the atoms are, and in what way the symmetry elements are related. So, this would be the best way to learn about the space groups in my opinion. Of course, you will by now you also agree because you are going through the course anyway. So, you will agree this is the best method anyhow. So, now these are the equivalent points. We get 4 equivalent points written as 1, 2, 3 and 4. These 1, 2, 3, 4 go to the references here. In fact, it is not marked here, but we can mark 1, 2, 3, 4. Given 1, 2, 3, 4, I would suggest that you mark the 1, 2, 3, 4 positions in the projection given here, which is 1, which is 2, which is 3, which is 4. For example, this is 1 and this is 4. So, the clue is already given, you mark which is 2, which is 3. So, these are the 4 equivalent positions, and there are special positions again in this space group. These special positions come like this. We have a position which is when the object is associated with the origin. So, if you take the origin and put x, y, z to be 0, 0, 0, then you will get 0, half, half as the second possibility. This will again be 0, 0, 0, this will be 0, half, half, the translation along y, the translation along z. So, the 0, half, half will be the second equivalent point. So, there will be 2 objects rather than 4 associated when they are sitting in this special position. So, you go to the other equivalent points, the other Wyckoff letters, we have 4 possibilities, and these 4 possibilities come at half 0, 0, 0, 0, half, half 0, half. What is very important here to remember and notice is that if there is a molecule associated with 0, 0, 0, it is a different situation because we have only molecules at 0, 0, 0, 0, half, half. So, if there is something which is associated with half 0, 0, that means this particular center of symmetry is different from this center of symmetry, that center of symmetry is different from that center of symmetry, and so on. And that is why the Wyckoff notations change. If all of them were similar, then Wyckoff notation would have been A and all the 8 would have been grouped under this. But that is not the case, because the way in which these operate, these 4 equivalent points operate, decides what are all the special positions. And therefore, we get 4 special positions, and these 4 special positions have a multiplicity of 2, and therefore, these are independent special positions. That means, if there is a molecule, let us say we take a cluster of molecules, there are 2 molecules, 2 different molecules, and they crystallize inside a P2 by C, and there are not very well defined interactions between these 2 molecules, let us say purely van der Waals interactions. Then the molecule 1 can sit here and the molecule 2 can sit here, and they can be in the 2 different special positions, that is allowed. And that way, in when you make the co-crystallization experiments, when you make co-crystals, when you make salts, when you make eutectics and things like that, it may so happen that these are the positions in which these molecules can sit, and they may have an interaction, they may not have an interaction between them, and that interaction is a question of intermolecular feature which is independent of the location of the molecules. So, that way we can have a molecule in this position and a molecule in that position, then you will have 4 of those molecules and 2 of these molecules, which will give a different stoichiometric ratio. I am mentioning these because particularly from the pharmaceutical point of view and also from materials industry point of view, these become very, very crucial. The way the molecules and them sit themselves in the allowed positions of the Wyckoff nature will tell us what is the nature of the molecule eventually, or what is the nature of the material which eventually comes out of this whole arrangement of supramolecular assembly. So, that way it is very important. The next thing we do is to we will skip the reflection conditions, because this will come only after we do scattering. So, we go to the next space group, which is the C centered space group and C2 by C. So, we know that C2 1 by C is the same as C2 by C, we already know that. Now, by looking at this diagram also, you can verify if you want to make a C2 1 by C, you move the origin to this fellow, then you will make it C2 1 by C, but anyway that is not important. What is important here is that this space group, again the unique axis is B, the full symbol is C1 2 by C 1. So, if you now convert this symmetry into point group symmetry, it will be 2 by m, and it is a monoclinic system. So, the equivalent point diagram is shown here, and you see now the asymmetric unit is halved in all 3 directions. So, it is half here, half there and half there. So, the moment that it is half, this fellow will not come up, and therefore, there are 2 of them present, one here and one there, or for that matter we are taking half the unit. So, this is half the unit and that is half the unit. So, there are 2 additional points due to the presence of the C centered lattice. So, since it is C centered lattice, the asymmetric unit will consist of 2 independent molecules. They are not dependent on each other anymore, and therefore, there will be 2 of those. Also, we notice here that the origin is located at 1 bar, and the glide plane C is coincident with 1 bar. What happens in that situation is that this particular notation tells us that there is a new symmetry that develops, and that symmetry which develops is the so called N glide. We talked about the N glides, and this N glide will develop in the case we have a C2 by C symmetry, and N glide, as you remember, will add not just half to one of the directions where we are now considering. For example, if you consider the glide plane associated with this origin, this is C and that is A. So, the translation symmetry that will be associated with the N glide will be half along C and half along A. So, the equivalent points will be x half plus y half plus z kind of a thing, and therefore, we now have invoking a new symmetry element into the system, which is now the N glide, and this N glide is now coming away from the origin and in a direction which is along the diagonal of A and C. So, there is a diagonal relationship like that. So, you see here that these 2, if you consider, they are related by an N glide, because it is half distance moved here and half distance up there. So, that is how you get the diagonal glide invoked. Now, the equivalent points now therefore, obviously will double. So, we will have 8 of those, and then we have several sets of special positions in this. You notice that all the special positions will generate 4 equivalent points, even though there are 2 types of special positions which come up. You see, so far in the previous examples up to this point where we discussed P21 upon C, the special positions had the same symmetry. In this case, it was 1 bar, but if you come to C2 by C, you see that the special positions are of 2 kinds. So, the molecules or the atoms or whatever they make up this structure, they can prefer the centrosymmetric positions for their special positions and get 4 of those, or they can prefer the twofold location, which is with respect to 0 y 1/4, and they can get again 4 positions. So, the presence of the twofold or the 1 bar symmetry, in other words, the molecule now can either possess a center of symmetry, or the molecule can possess also a twofold symmetry. If the molecule possesses a twofold symmetry, it will go and sit with respect to the twofold axis, which is now a special position. So, you notice that the Wyckoff notation, the highest symmetry is always with respect to 0 0 0. So, it is going up there, and we see that 4e is a position where you can have a twofold symmetry. So, objects which have twofold symmetry preferably sit there rather than in any one of these positions, because these positions insist on having the center of symmetry. So, if the molecule has a center of symmetry, it prefers to go into these 4 positions, and if the molecule has a twofold symmetry, it prefers to go to that particular system. So, this analysis of the equivalent points, you can do it very easily now, because you have the 8 equivalent points listed up there. Take any one of these, for example, you take 0 y 1/4, substitute that into these 8 positions, you will end up with 4 positions, and those are the 4 positions corresponding to the Wyckoff notation for E, and that is how we get the C2 by C space group. So, the discussion so far has been now with respect to the monoclinic symmetry. We have discussed the triclinic symmetry, we have discussed the monoclinic symmetry, we have discussed the equivalent points, we have discussed the equivalent point diagrams, we have discussed the symmetry diagrams. so much of knowledge now pumped in the last maybe three or 4 classes, but what is very clear about this whole thing is that the symmetry is the driving force. So, the moment we have understood the symmetry over the previous classes, this now becomes a straightforward understanding. So, looking at an international table, it does not look anymore like Greek and Latin, it will look like something which is very grammatically correct. Since we have understood all the grammar associated with the equivalent points, with the space groups, with the point groups and so on, it becomes a very facile thing to read the international tables. In fact, international tables, I should have brought it here, it is a big thick book, it is like, looks like a telephone directory, and initially if you look at it, it looks very ugly because all these pictures are there and you will think it is like as insipid as a telephone directory. But then once you have got all the grammar understood, now you can read from one end to the other of the international tables, which I do not suggest you do because it will take half a lifetime. But what is interesting to observe is that all these were worked out before any experimental method of determining structures were found out. So, people looked at crystals sitting in one place, like I am sitting for your class always here. So, in the more or less the same position, there is no change in the position, I am stuck here. So, like this people used to be stuck, and the fellow who was stuck was in fact sitting at minus 30 degrees in Siberia. So, that poor fellow sat there and looked at the crystals and then arrived at all the possible space groups, identified the crystal systems, looking at crystals, the shapes of the crystals, doing stereographic projections. He created the 32 point groups, and this was way back in the 18th century, 1730, and this is remarkable. But then if you happen to visit Siberia, you will know why he could only do that, because the temperatures there are on average very low and it is always iced up. You can't go out and have enjoyment unless of course you go skiing around, and that is also very dangerous, and therefore you sit in one place and do this. And what is remarkable is all these were derived and shown. X-ray diffraction experiments, when they came, they showed some of them are wrong, not all are wrong, but some of them are wrong, and therefore it is very important that you have now learnt the grammar. So, you can now start reading the text. What is the best way to read the text? You do not feel like reading your textbooks regularly. Instead, if you are given a Harry Potter book or a Lord of the Rings book or some novel, some interesting spy novel or something, you will prefer to read it. Of course, nowadays reading itself is avoided. You read again on this stupid thing. I am also now teaching it on this one, even though I personally prefer teaching with a board and a chalk, which is what I do even now in my other class when I teach here in IISc. But then, well, we are all victims of modernization and computers have taken over. Eventually with artificial intelligence coming up in full swing, computers will probably rule us. Computers will tell, hey, you do not know how to teach, I will come and teach, and such a day will come very soon. So, it is completely automatized, and automated understanding of everything will be clear. So, then I do not think we need the grammar or anything that is associated with. We can always go ahead and then determine this.